Today we'll be using the combined gas law. A combined gas law problem may sound something like this. A balloon has an internal pressure of 1.05 atms at 55 degrees Celsius. If the volume is 8.0 liters, what will happen to the volume when the balloon's pressure decreases to 0.65 atms and the temperature is decreased to 40 degrees Celsius? Now we know that our combined gas law equation is our initial pressure multiplied by our initial volume divided by our initial temperature is equal to our final pressure multiplied by our final volume divided by our final temperature. Now the given information in the problem is our initial temperature is 1.05 atms, our initial volume is 8.0 liters, and our initial temperature is 55 degrees Celsius. We know that our final volume is 0.65 atms and our final temperature is 40 degrees Celsius. Now in order to use the combined gas law, we must convert our temperature from Celsius to kelvins, and in order to do so we add by 273. Which gives us 328 kelvins for our initial temperature and 313 kelvins for our final temperature. Now we know that we're solving for V2, so that means we have to rearrange our equation to solve for V2. In order to do so, we must isolate V2. And to isolate V2, we must multiply both sides by T2 and then divide by P2. And that gives us the equation V2 equals our final temperature multiplied by our initial pressure multiplied by our initial volume divided by our initial temperature multiplied by our final pressure. Now to solve, we input our given information, and that gives us 313 kelvins multiplied by 1.05 atms multiplied by 8.0 liters divided by 328 kelvins multiplied by 0.65 atms. Now we must make sure that all our units except liters cancel out because we are looking for volume. And our final answer is volume 2 equals 12.3 liters.